Hi guys, welcome to lesson 7.1a, classifying angles. We're going to go through a few definitions to start off today. The first one is perpendicular lines. These are two lines in a plane that form a 90-degree or right angle. There are two ways that we show perpendicular lines. So this is a symbol. It's kind of an upside down T that tells us that we have two lines that are going to be perpendicular. And then the other one I'll show you on our example. So we have a line, we have an angle, and we have this little symbol right here. That is another example of a perpendicular line. Another symbol for it. Parallel lines. We've talked about this before in the systems of equations chapter. We've talked about it in solving equations. So parallel lines are two or more lines in a plane that will never intersect. And a plane just means a flat surface. Now, you see it symbolized a couple ways. One would be these two lines that look like just kind of two L's. That could mean parallel. And you'll also see it on little tick marks on the lines. So we have two lines here, and I'm going to draw my arrows to show that they are, in fact, lines, not just segments. And what you might see, there's two different ways. You could either see like a little chevron, so a little arrow on it. That indicates they're parallel. Or you may just see like a little tick mark on the ones that are parallel. Okay, sometimes if there are multiple sets of parallel lines, you may have two tick marks to show or two chevrons that'll show that those specific angles are parallel. Now, a transversal, this is a line that intersects two or more other lines in a plane. Intersects two or more lines in a plane. So we have our original two, and we're going to go with parallel lines for this case. So I've got my arrows on them. And I'm going to indicate that they are parallel using that little chevron. Now a transversal is going to be a line that cuts across them like that. That is our transversal. Okay. We're going to move on to our next page. Our next page is going to talk about some more definitions. Complementary angles. These are any two angles whose sum is 90 degrees. Okay, sum is 90 degrees. So if we have one angle and that's 30 degrees, and we have another angle and it is 60 degrees, their sum is going to be 90 degrees. 30 plus 60 is 90. They're complementary. Now, supplementary angles, these are any two angles whose sum is 180 degrees. So again, we've got our lines, and let's say this one is 30, and now we have one that's much bigger, and this is 150. Those two are supplementary angles. They add up to 180 degrees. Next up, we have adjacent angles, and adjacent angles are two angles that are next to each other. and they share a common side. So I'm going to start by drawing an angle. Okay, so we've got 3 rays, and then we have adjacent angles, A and B. They're 2 angles that are sharing a same side. Okay. All right. Our next definition, I'm going to leave adjacent angles there because linear pairs are 2 angles that are adjacent and supplementary. They form a straight line. Okay, so now this would be, we've got a line here, and then we have a line coming off of this. And let's say this is 100 degrees, and this is 80 degrees. Not drawn to scale, but that would be an example. You have 2 angles that add up to 180 degrees, and they are adjacent. They are sharing a common side. They add up to a straight line. So if we compare this to supplementary angles, a linear pair is a supplementary angle, but the key is linear pairs have to be a straight line when they are finished. Okay, a linear pair must be a straight line. And supplementary angles, they could just be any 2 angles that happen to add up to 180 degrees. Okay, so linear pair is a more specific type of angle than just being supplementary. All right, vertical angles are 2 angles across from each other on intersecting lines. They are always congruent. And congruent also means equal. Okay, so this would be if we've got 2 intersecting lines, draw my arrows to show that they are angles. This angle right here and this angle right here are the same. They are exactly the same. They're across from each other and they're the same measurement. So that means this angle and this angle are both the same. They're both equal to each other. So vertical angles go across your intersection point. Interior angles are the 4 angles formed on the inside when a transversal intersects 2 parallel lines. So we draw our 2 parallel lines. Okay. I'm going to use a tick mark to show that they're parallel. And we have a transversal that's cutting across. Our interior angles are going to be here, 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 and here. Interior means they are inside of the parallel lines. Interior, inside. So our 4 interior angles are right there. Exterior angles are going to be the 4 angles formed on the outside. They're on the outside when a transversal intersects. So we draw our parallel lines again. Okay, arrows on the ends. And we're going to use the tick mark again to show that they're parallel. We have our transversal. So these are going to be the line or the angles on the outside of our parallel lines. Exterior angles are on the outside. Exterior angles are on the outside. Okay. Now, we're going to go on to do some examples of identification. So our first example here, we have two angles that are sharing a common side. They are adjacent to one another. We want to be the most specific possible, and we see that one is 140 and one is 40, and those two are going to add up to 180. So we have that they are adjacent and they add up to 180. Therefore, this is a linear pair. Okay, they are supplementary, they are adjacent, they are a linear pair. Okay, next one we are looking at where these dots are, and they're in the middle, so those are interior angles. Okay, our next two, notice they are across from each other. They're across the vertex from each other, so that is vertical. Vertical angles. Now, for this one, we're not given any measurements. We're just identifying these two angles. We can't assume that they are going to be 90 degrees because we don't know. We have nothing indicating that for us. But we do know that they're touching each other. They are sharing a common side, so that means they are adjacent. They are adjacent angles. Next up, we have these two. So it looks like I have some parallel lines. I've got a transversal, and I'm looking for these right here. Well, they're on the outer edge, so these are going to be exterior. They are exterior angles. They're on the outside. Okay. So we have next 65 and 25 degrees. 65 plus 25 is 90, so that makes these complementary. Okay. Our next one, we have two angles. They are not touching one another, but they do add up to 180 degrees, so those are supplementary. Okay. And our final one we have here, we have two angles. It looks like they are making a straight line because that line isn't broken there at all. And they are touching one another, so that is a linear pair. Okay, they are a linear pair. So we're going to go on to our next page and learn a couple more definitions that are going to extend these a little bit. Our first definition is alternate interior angles. These are interior angles, so they are on the inside, that lie on opposite they're on opposite sides of the transversal. Alternate interior angles are congruent. So, alternate interiors, they are going to be on interior angles on opposite sides of the transversal. So, this one and this one. They are interior, they're in between our parallel lines, and they're on the opposite side of our transversal. So they're in between the two parallels on the opposite of the cutting across. There is a second pair of angles that are alternate interior, and again we can see they are on the inside of our parallel lines, and they are on opposite sides of the transversal. So we have two sets of alternate interior angles, or opposite inside angles. And they're congruent. So I said y and y, x and x, because they are equal to each other. They are the same. Okay, next up, alternate exterior angles. These are going to be exterior, as the name indicates. Angles that lie on opposite sides of the transversal. Alternate exterior angles are congruent. Okay. Alternate exterior angles, so we have X and X. We have Y and Y. Okay, and again, I'll use the laser pointer. They're on opposite sides of the transversal, and they're both outside of the parallel lines. Okay, so they're on opposite sides of the transversal, and they're on the outside of the parallel lines. Now, corresponding angles. Corresponding angles are two angles in the same position on the same side of the transversal. They are congruent. So, same position on the same side of the transversal. So we're going to say this is 1 and this is 1. They're on the same side of the transversal. They're in the same position. They're both above the parallel line. We'll say this is 2, this is 2. We'll change colors. We'll say this is 3, this is 3. Change colors again. Go purple, 4, and 4. So again, if we look at our parallel lines, okay, look at our parallel lines on the transversal. 1 is going to be above the parallels and to the left of the transversal. 2 is above the parallels and to the right of the transversal. Same for 3 and 4. 3 is below and left. 4 is below and right. They are congruent. They are exactly the same. And you can see when you look at those two angles, those look like they are the same angles, right? This one and this one. Those two angles look the same because they're identical. They are congruent. Okay. Now, consecutive interior angles are a pair of interior angles on the same side of the transversal. Consecutive interior angles are supplementary. Okay, so supplementary angles, they are these two angles and these two angles. Okay, so those two angles will add up to 180 degrees on the left side and on the right side. So that right there, you've got one angle that is narrow, one angle that is wider. So those two add up to 180 degrees. Okay. So now we're going to do a page where we're going to identify what we have. Now, this first one, they are on opposite sides of the transversal. Okay, they're opposite sides of the transversal, and they're on the outside, so this is alternate exterior angles. AE, alternate exterior. Now, this one, they are in the same position on the same side of the transversal, so this is corresponding. Okay. Our next two examples. We have two angles that are interior angles, and they are next to each other, so this is consecutive interior. Okay, consecutive interior. They're on the same side of the transversal, and they are next to each other. Okay. Our next one, they're on opposite sides of the transversal, and they're in between our two parallel lines. So this is alternate interior angles, AI, alternate interior angles. Okay. My next example, they're in the same position on the same side of the transversal, so that is corresponding. Okay, corresponding angles. Our next one, they are in between the parallels, so they're interior, and they're on the same side, so that means they are consecutive interior angles. Consecutive interior angles. And our last two examples here, we have two that are directly across from each other. Those are going to be vertical angles. And then we have another pair where it's opposite sides of the transversal. They're on the inside, so that is alternate interior angles. Those are our notes for today. Stay tuned for the next video for 7.1b, how we are going to find missing angle measurements using all of these rules we've just gone over. Have a great day.